Well, hello there everyone. We are talking about Endgame finally. And by that I mean we are talking about the final section of the final chapter of the final week of our course. And so I hope you're as happy to be there as I am. It's been a long, fruitful haul. And this last section is certainly a marvelous exposition of the power of math to model various applications. I know a lot of you don't like word problems, but the ones in 9.7 are fascinating. They really do show the power of exponential functions to model various aspects of our universe. So this problem I think is quite interesting. It's actually number 2, early in the problem set. And like most of these problems, it consists of multi-parts. And I suspect part B is very troubling for a lot of you, and I'm going to work that in a separate video. So let's get rid of that and let's just focus for now as quickly as possible on part A. The problem itself says that the number of unique visitors per month to Facebook T months after April 2006 can be estimated by this function, or if you will, this formula, where the output f of t is in millions, and they give us this exponential function. So somebody came up with this by looking at the data and by making certain extrapolations, and that's true for a lot of the way science works. And once you have this, you have predictive abilities, and that's really what part A is all about. Part A asks us how many months after April '06 until the number of Facebook visitors reaches 1 billion. Now, I'm going to solve that, but I wanted to point out something that's needs to be magnified here. I think the the place where a lot of the errors are made is in terms of the output here. The initial wording of the problem tells us that the output is in terms of millions. So what that means is, for instance, if I wanted to crunch this out for some t, let's just do that. Let's pick the initial value for t, which would be t is equal to 0. When we let t equals to 0, in other words, when we look at the number of Facebook visitors as of April of 2006, what is the output? And so we would put 0 right here. And of course, any base to 0 is going to generate 1. And so the output is very easy to see. It's just 1 times this. In other words, it's just this. So the output is going to be 11 point, let's round it up to tenths, 11.8. So when t is equal to 0, f of t is equal to 11.8. And so that's in terms of millions. We're talking about 11.8 millions. Now, when we go to solving this part right here, I think many of you will be tempted to write the equation like this. You want the output to be 1 billion, and you want to solve this for t. You want to know what value of t, how many months after April 2006, will generate 1 billion unique visitors to Facebook. And that's almost correct. The problem is the output has to be written in terms of millions. And so the question that needs to be asked is, how many millions really are there in a billion? And the answer to that is actually this bit right here, because 6 zeros represent a million. So there's 1,000 million in a billion. And really, the correct equation here, and this is very tricky, very sly, the correct equation here is actually this one right here. We want the output to be 1,000 because we are talking about 1,000 million, which really is a billion. And this is the equation that we need to solve for t. Okay, well, I hope I didn't lose you on that. If I did, I suggest you perhaps listen to it again, or better yet, sit down with a pencil and scratch your head over the fact that the output is in terms of millions. Okay, now, the way to solve this is given in earlier sections. Essentially, we're going to isolate the base and its unknown, which is the exponent here, by dividing both sides by 11.755. And that looks like this. And of course I was very tempted, like most of you will be tempted, to crunch out that fraction to the left. And so I went ahead and got my calculator and did that. And now here we go to the essential moment. How do we solve for an unknown that's an exponent? And that's a two-step process. The first step is you take the log of both sides. And you could take the log of to any base. I'm going to take log of both sides using the natural logarithm to the base e. And so that's what I've done right here. Well, how does this move us closer to liberating that t and solving for that t? The answer is in the third law of exponents right here. As you can see, when you're taking the logarithm of some number that's to a power, in this case our power is t, you can rewrite that as a product out in front of that logarithm. And so that's what we're going to do. We're going to evoke the third law of logarithms, and we're going to rewrite this like this. The t comes out in front as a multiplier, and now it can be solved for by dividing both sides by ln to the 1.109. And that is in fact my next move, and looks like this. So there you see it. We've solved for t. All that's left is to do the calculator grunting. And of course, you know me, I'm going to bring in a Wolfram Alpha window. And as you can see, here's my input. This will generate the value of t, and here's the result right here. T is almost 43 months. We rounded up to 43 months. And so that becomes our answer. Let me get this out of the way, and let me box my answer. So in 43 months after April 2006, there will be 1 million unique visitors to Wolfram Alpha. And that is one part of the answer in the back of the book. The other part was actually figuring out how many, exactly what year and month 43 months after April 2006 is. And I wanted to see if Wolfram Alpha could solve that for me and save me a lot of trouble. And so what I did is I typed in April 2006 and said add 43 months to that. And sure enough, it told me November 2009. So essentially, we're talking about, if the formula was correct a month ago, then, or near enough, Facebook had its 1 billionth unique visitor. That is, if it continues to grow exponentially since the equation was created. Well, I hope that helps. I'm going to get after part B now, which I think is a bit tougher, and I'll see you in a few minutes.